Hello, this is section 6.5, determinants and Cramer rule. So this is the fifth ways you can solve the system of the linear equation, which is first one was graphing, second one was substitution, third one was elimination, and matrices, and then the determinant. So objectives, number one, calculate the determinant of the square matrices, and number two, solving system of the linear equation using Cramer rules, and number three, inconsistent and independent systems and Cramer rules, and number four, optional diagonal method for the calculation, 3 by 3 determinant. So calculating the determinant by square matrix. In this section, we will use a Cramer rule, which is a Cramer guy found us, a rule that rely on the calculation several determinant to solve the linear system of the equations. So we begin this section with a discussion on how to calculate the determinant of the given square matrix. So let's do with a 2 by 2. So when you have a matrix has a 2 by 2, which is 2 rows and 2 columns, A, B, C, D, we have here. And then in order to find the matrix, we use the bar instead of the bracket. And then determinant for the matrix A means we write this as a bar, and then you have a cross product to difference of the two cross products. So AD times AD times minus and BC. Okay, so this is how you do it. Alright, so 2 by 2, what do? You multiply 3 by 7, subtract, you multiply 2 by 5. Which means 21 minus 10, answers are 11, because that's a determinant. As a B, same thing, you multiply negative 4 and 8, and subtract, you multiply that, which is negative 3 times 5. So negative 32 plus 15, right? So you got the negative 17. Same one here too. So you multiply 0 times 9, subtract, and 1 times negative 6. So you got 0 plus 6, answers are 6. So that's a determinant for 2 by 2. So in order to calculate the value of the determinant for 3 by 3 matrix, we need to define the minor of entry in a matrix. So a minor of any element of the square matrix is a 3 by 3 or greater is a determinant of the matrix obtained when the row and column include the elements are deleted. So consider the following matrix we have. So 3 by 3, right? The minor associated with the 1 in the first row and the first column, denoted as this one. So the first one is a row and second one is a column. So row by column. So when they said that the system, this is number of the row and this is number of the column, where the first digit of the subscript denotes the row of the second digit denotes the column, and the entry we are considering can be found by investing the matrix with the row and column contain the one deleted as follows. So if I say the minor for first row and the first column, which means you are not using this two, only use a number that is not a first row and the first column, which means you can write as 2976. So that those are the minor. Okay, let's find the minor associated with the 9 in the second row, the third column. So I think they're talking about the 9 in here, which is row 2 and then column 3, which is 9. Which means that we're not gonna use any same row as a 9, any same column as a 9. So whatever number you found is 1, 5, and 4, 7. That's a minor for that case. Now to calculate the 3 by 3 determinant, we picked any row and column of the given matrix. So suppose for each matrix we choose the top row. So you have a first row and the first column, which is the 1, right? So we are not using this to this. So we got 2976. And then the first column and the first row and the second column, which is a 5. So we are not using first rows and the second column, which is you got 8, 9, 4, 6 as a minor. And then the first row and the third column, which is this, which is we're not using that as the minors as a 8, 2, 4, 7. So in order to calculate the determinant, we must multiply each entry, the chosen row, by its minor, and then add or subtract this value using the follow charts. So actually the 3 by 3, there's actually the sign for the location. So location sign is this one. Since we chose the first row, we must add a 1 times its minor, subtract 5 times its minor, and then add a 3 times its minor to calculate determinant as follows. So what does that mean is, okay, so I'm using the first row, okay? So first row has a sign of this. So sign will be the 1 is a positive, 5 is a negative, and then 3 is a positive. So what if you already have a negative? You got to multiply the two signs together. So which means 1 as the first number, and the minor will be the 2976. And then 5, but 5 is the sign of negative, and the minor is 8946. And then 3 is a positive, and minor is 8247. And then you just need to calculate this. So that's exactly what they say here. So 1 times up, you got to cross multiply 12 minus, multiply this 63, minus 5 times up, multiply that is a 48, minus 36, plus 3 times up, 56, minus 4 times 2 is 8. So 1 minus of negative 51, minus 5 times up 12, and plus 3 times up, which is 46. 48, sorry, 48, right? 48 plus 56, right? Okay, and then I got negative 51 minus 5 times 10, 60, and plus 48 times is 24, 12, 41, 44. And then you just need to subtract them out as 144, and then negative 51 minus 60 is negative 111. So 111, I have 33. So that's the answers. So 2 shows that the choice of the row and column is irrelevant. Let's calculate the determinant using the middle column. Okay, let me find the calculator, okay, so that I can use the, don't have to worry about that. Okay, go here. Alright, so 2 sign chart of the center is sign we have right here. So we are using the middle column here, which is this one. So in order to do that, sign is a 5 is a positive. No, oh no, sorry. It's going to be the negative, positive, negative. So if I use a 5 as a negative, and then the minor is going to be the 8, 9, 4, 6. And then for the 2, the minor is 1, 3, 4, 6. For the 7, is the minor is 1, 3, 8, 9. And then just compute this. Negative 5 times up, multiply this 48 minus 36, plus 2 times up, multiply this 6 and minus 12, minus 7 times up, 9 minus 24. So I got negative 5 times up, 12, plus 2 times up, negative 6, minus 7 times up, negative 15. So now I have a negative 60 minus 12 plus 15 times 7 is 35, 105. So negative 72 plus 105. I got 33. So do you see we got the same answer? So previous one we got 33 is because it's the same elements. So find each of the following determinants. So you can choose whatever you want. But the for me is, I love to using the first row. Okay, so I'm using this one. So sign for each one is positive, negative, positive, right? So I do as determinant is 3 of minor, oh sorry, I have to put the matrix system, sorry about that. So equal to 3 of negative 2, 5, and 1, and 7, and negative 2, 1, 5, 6, 7, negative 4, because 2, when you have a positive negative, it becomes negative. And then you got 1, negative 2, and 6, and 1. So I got 3 times of negative 14 minus 5, negative 2 of 7 minus 30, negative 4 of 1 minus negative 12. I got 3 of negative 19 minus 2 times of negative 23, and negative 4 times of 13. So I have the calculations of the problem is I got negative 57 plus 46 minus 52. So I got negative 63. Okay, now I'm using the first row too. Okay, here. So this is going to be positive, negative, positive, right? So as 2, minor is 2, negative 3, 1, 0, minus 4 of negative 5, negative 3, negative 4, 1, 0. And then as a 0, I got negative 5, 2, and negative 4, 1, but I don't need to worry about that thing. So it's going to be the 0 minus negative 3, minus 4 of 0 minus the 12, and then 0 times of any number is a 0, yeah, which is a 5 minus of negative 8, of course. And then I got 2 times of 3 minus 4 times of negative 12, and then 0. I got 6 plus 48 plus 0. I got 54. Okay. Alright, so Cramer rule for the system of the linear equation. After learning to calculate the determinant of the square matrices, it's time to see how we can apply them to solving a linear system. For this purpose, we have a Cramer rules. So Cramer rule for the system of the two linear equation, we are using the determinant. So given the linear equation as the form I have, and then in order to find it, we need to find the determinant for x, determinant for y, and then of course we have to find the determinant. So determinant is from the a1, b1, a2, b2. And x is instead of the a1 and a2, you use the constant term, which is c1, c2, and then keep the b1, b2. For the dy, instead of the b, we're using the c1, c2 to get the determinant for the y. So a simple method to remember what value are contained in each of the three determination is to recognize the following. So D is A1, B1, A2, B2. D sub X is C1, C2, B1, B2. And dy is A1, A2, C1, C2. So when you consider this equation, and then, yeah, that's what you do. Yeah, so that kind of explains why we get those. As if you want to read it out, you can read it out. That's fine too. Okay, so let's do the using the Cramer's rules to solve the problem. So for the determinant, so you have to see the coefficients: negative 3, negative 4, 1, and 2, 5, and 16. So this is A, B, C. You should know that. Okay. So for the determinant, I use A and B, right? So I got 3, negative 4, and 2, 5. Okay, so how do you get the determinant? We got multiply, right? So 3 times 5, 15 minus of negative 8, which is 23. And then this sub x, I'm using the c, which is 116, and negative 4 and 5. So cross multiply 5 minus of 16 times 4. I think it's a 64. So negative 64, which is 64 plus 5 is 69. And this y is, I'm using the 3 and 2, but I'm using the 1 and 16 for the C, for the B place. So multiply 48 minus 2, which is 46. So in order to get an x, it's going to be a ratio of the this of x over d, which is 69 over 23. I think it's 3. As a y, dy over d, which is 46 over 23. I think it's a 2. So your answer is going to be 3 and 2. So it's not bad, right? Same thing. Find the d. So, ABC, so 8, 3, 4, negative 9, which is cross multiply negative 72 minus 12. So I got negative 84. And this sub x is, I got 35 and 3 and negative 9. I got negative 27 minus 15. I got negative 42. This sub y, I'm using the 8 and 4 for 3 and 5. And then I have 40 minus 12, which is 28. Yep. Okay, and then in order to get an x, this sub x over d, I got negative 42 over negative 84. Okay, I think this is a half. And then y, this is a y over d, which is 28 over negative 84. Okay, so 28, I think 28 goes 7, 4 goes there. 4 goes 28 7 times. It's going to be the negative 21. Oh, so it's a 1/3, isn't it? Okay, so negative 1/3. So solution is half and negative 1/3. Okay, so that's how I find the order pairs. Expanding the Kramer-Rother system, 3 linear equation will require the calculation of the 4 determinant, each one of the 3×3 determinants. So Kramer-Rother for the system of 3 variable, we have a D. So yeah, same way we just have extensions. Okay, so we have a Z right now. So this is how you use. So similar to rule for the system of the 2 linear equation, determinant D is determined by the coefficient and each of the determinants dx, dy, and dz have the x, y, and z column of determinant D replaced with the constants respectively. So example 5, solving the following linear system using the Kramer rules. Okay, so this is A, B, C, D, right? So in order to get a D, I got 2, negative 3, 1, and 3, 1, negative 2, negative 1, 4, and 2. Then I'm going to solve this, okay? So I need to choose the row or column to figure it out, right? But my favorite was, that the first row, right? So positive, negative, positive. Okay, so I'm going to do 2 times up. 1, negative 2, and 4, 2. And then 2 negative become positive 3. Now I have a 3, negative 2, negative 1, and 2. And then I got 1, which is 3, 1, negative 1, and 4. So I got 2 of multiply across 2 plus 8 plus 3 times 6 minus a positive 2 plus 1 times 12 plus 1. So I got 2 times 10, 3 times 4, 1 times 13. I got 20 plus 12 plus 13. So 20 plus 12 plus 13. I got 35. Alright, this sub x. So this sub x, I'm using the D for the A. So negative 1, 9, and negative 7. And the other places stay the same. Negative 3, 1, 4. 1, negative 2, 2. So same thing. I'm using the first row. So positive, negative, positive. So negative 1 minus 1, negative 2, 4, 2. Positive 3, I have a 9, negative 2, negative 7, and 2. And then positive 1, I have a 9, 1, negative 7, and 4. So I have a negative of 2 plus 8, 3 of 18 minus 14, plus 1 of 36 plus 7. So I got negative 10 plus 3 of 4 plus 43. So I got negative 10 plus 12 plus 43. Then I get I get 45. Alright, this is y. Now I use 2, 3, 1. And then instead of the b, I use a d. So negative 1, 9, and negative 7. And then I got 1, negative 2, and 2. So I'm using the first row, positive, negative, positive, right? So I'm using 2 times 9, negative 2, negative 7, and 2. And plus 1 of 3, negative 2, 1, and 2. And plus 1 of, I have a 3, 9, 1, negative 7. So I got 2 of 18 minus 14 plus 1 of 6 plus 2 plus 1 of negative 21 minus 9. Then I get 2 times 4 plus 8 plus negative 30. So I got 8 plus 8 minus 30. So 16, so negative 14. Alright, this sub z. This sub z I got 2, 3, negative 1, negative 3, 1, 4, and negative 1, 9, and negative 7. So I'm using the first row, positive, negative, positive. And then I'll get 2 of. I get 2 of 1, 9, 4, negative 7, plus 3 of 3, 9, negative 1, negative 7, minus 1 of 3, 1, negative 1, and 4. So 2 of negative 7 minus 36, plus 3 of negative 21 plus 9, minus 1 of 12 plus 1. So I got 2 of negative 43, plus 3 of negative 12, minus 1 of 13. I got negative 86 minus 36 minus 13. And then what I get is, I got negative 135. Okay, so now we got every determinant, right? So x is d sub x over d, which is 45 over 35 divided by 9. It's going to be 5 over 7. Y, this y over d. This y is a negative 14 over 35 divided by 7, negative 2 over 5. Z is negative dz over d, negative 135 over 35. If I reduce by 5, it's going to be 7. 5 goes negative, which is 5 goes 2 times 27. So answers are 5 over 7, negative 2/5, negative 27 over 7. Yep, so answer could be the odd fraction too. So Cramer rules an inconsistent or dependent system, and noticing that each variable is ultimately defined by a rational expression with the denominator determined by the value d. We should understand that in order for the expression for each variable to be defined, so Cramer rule requires d shouldn't be a 0. But as seen in the last example, any of the determinant d sub x, y, and dz equal to 0 is not an issue, but only for the d. So this is shouldn't be. But what if it is? So to try to solve each of the following linear system using the Cramer rules, okay? So let's say d is, I use a 3, -4, -6, and 8. So I got cross multiply 24 minus 24, which is a 0. And this sub x is, I got -1 and 2 with a -4 and 8. I got -8 plus 8, which is a 0. Oh my goodness. dy is, I got 3, -6 with a -1 and 2. I got 6 minus 6 is 0. So, oh my goodness, everything come out to 0, right? So, d and dx and dy, which is x is going to be the d sub x over d, which is a 0 over 0, which is undefined. And y is also dy over d, which is a 0 over 0, which is undefined too. So, everything come out as a 0. This is going to be the infinitely many solution, which is dependent on each other. Okay, for this one, so let's see what we get here. So d sub x, so d is, I got 3, 1, 2, and then 1, 2, -1, and then 1, -3, and 4. Then I got as, using the first row with a sign of positive, negative, positive. So I have a 3 of 2, -3, and -1, 4. Minus 1 of 1, -3, 2, 4, and plus 1 of, I have a 1, 2, and 2, -1. So 3 of 8 minus 3, -1 of 4 plus 6, plus 1 of -1 minus 4. I got 3 times 5, minus 10, and minus 5. So I got 15 minus 15, which is a 0. So once you have a d equal to 0, but let's check the d sub x. So d sub x is, I'm using the 4, -1, and 6, and then I got 1, 2, -1, and 1, -3, and 4. And then I'm using the first row with a plus, minus, plus. So 4 of, I have a 2, -3, and -1, and 4. Minus 1 of -1, -3, 6, and 4. And plus 1 of, I got -1, 2, and 6, and -1. And then in order to find the 4, 8, and then plus, minus 3, minus 1 of -4 plus 18, plus 1 of 1 minus 12. So I got 4 times of 5, -1 times 14, and plus 1 times of -11. I got 20 minus 14 minus 11, so which is a 26, right? So -6, -5, right? So it's not equal to 0. So this time, but these are 0 already, so it's going to be undefined, but d sub x is a -5, so you don't have to find the other y and z. This is the case of the no solutions. So in general, anytime determinant d equal to 0, this sum will be the inconsistent or dependent, having a no solution or the infinitely many solution respectively. So this is optional, so I kind of like it this way though. So in order to solve this one, I'm using the diagonal method, or but we call it as a weaving basket, which is the summer basket. Some basket use the bamboo skin, and then they're making a basket. So because they come this way, okay. But also you can call the diagonal method, okay. So we have to calculate all 3x3 determinants in the chapter by choosing a row and column and expanding into an expression involving minors. The importance of this method is in seeing the pattern that exists with a larger and larger determinant, and therefore they allow us to expand the concept to any size of matrix. However, we are calculating a single 3 by 3 determinant. We can use a method or described as a diagonal method. So I'll show you how to do it. So consider the first 3 by 3 determinant. So we are using for the 3 by 3, okay? Not 2 by 2. We discussed in this section. So we have the determinant, and then the first step in the diagonal method, we copy the first two columns. So we are copying these two columns. So which means we write this as next to the bar. So I put the 1, 8, 4, and then 5 and 2, 7. And then once you done that, we are weaving basket, okay? So what I do is I'm going to multiply diagonally. So 3 number together. So starting from the 1, okay? And then I'm making a diagonal. So I'm going to multiply this plus this and plus this, okay? So with in parentheses, okay? So in parentheses, I'm going to multiply 1 times 2 times 6, which is a 12. And plus, I'm going to multiply 5 times 9 times 4, which is 180, right? So 180 plus, and then I'm going to multiply 3 times 8 times 7, which is 24. 24 times 7 is 168. And then you gotta subtract, because it's just like diagonally we multiply and subtract the other product. Now next one, in parentheses, now I'm gonna multiply diagonal going up. Okay, so 8 times 2 times 3, which is 24, plus, and then I'm gonna multiply 7 times 9 times 1, which is 63. And then I'm gonna multiply 6 times 8 times 5, which is a 240. And then I'm gonna just do the calculator here. So inside I got 12 plus 180 plus 168. I got 360. Subtracting 24 plus 63 plus 240. 327. And then you subtract each other. I got 33. So this is the answer. I think that we have 33 at the time, right? So in general, we can shorten this process by adding the 3 downward diagonal product and then subtracting each of the 3 upward diagonal product, okay? So example 2A again from the problem we have, okay? So what do you do is we are going to the repeat, okay? So I'm going to repeat the 3, 1, 6 from the first two column. 2, -2, and 1. So what I do is I'm gonna make a diagonal downward, which is the 3 times -2 times 6, which is a -6 times 42. And then I'm gonna multiply 2 times 5 times 6, which is 60. And then multiply this, -4 times 1 is -4. And then subtract. And then I'm gonna multiply upwards from the 6. So 6 times -2 times 4 is 8 and 48. And then I'm going to multiply 1 times 5 times 3, which is 15. And then multiply 7 times 1 times 2 is a 14. And then just simplify. So I got 60. It's 46, right? So I got 14 minus up 48 plus 15 plus 14 is 77. And I have a -63. Isn't it a lot easier? So I don't know. If you like it, you can use it. This will always work for this problem. Okay? Alright. Thank you for listening.